I forgot to write number 109 first, but anyway, we have 109 and 111 that are based on the same information that we're given. Initially, we're given g of 2, h of 2, g prime of 2, and h prime of 2. That's what these values are. And looks like we're trying to find for both of these f prime of 2. So we'll do number 109 first, since the number is first. But f prime of 2, we have to first find f prime of x. And f prime of x. Now, this is an interesting look here. You're doing the same thing. You're just not given what actually g of x is or what h of x is. But that doesn't change the fact that you still use the same rules. And so f prime of x is equal to 2 times g prime of x plus h prime of x. So that's it. That's all you really have to do to find the derivative f prime of x. But we don't want to stop there, because we want to answer the question. F prime of 2 then, since f prime of x depends on x, f prime of 2, would we just replace x with 2? That's it. And we're given those values. That's why we're given those values up here. G prime of 2 is negative 2, and h prime of 2 is 4. So we have negative 4 plus 4. So f prime of 2 is 0. That's not a very good 0, but there you go. F prime of 2 is equal to 0. And let's see here. Then for problem number 111, you might, I would urge you to always do this, by the way. Once you think you have it figured out, maybe you do, and I would pause the video. Don't just watch me do it. You try it first. And so I'm going to do number 111 now. So if you want to try it on your own, go ahead and do that. Pause the video and then play it when you're ready. So f prime of x, noticing we have f of x is defined as the quotient of two functions, and so we want to use the quotient rule. And the quotient rule is low d high, so the denominator multiplied by the derivative of the numerator, minus high, got kind of squeezed in here, high d low. So low d high minus high d low, which is h prime of x, all over low squared. And so we have f prime of x. There's no need to do any simplifying, nor do I think we could simplify that anyway. And our ultimate goal is to find the first derivative, f prime, at the x value of 2. That's what it asks for. And so we want to notice that f prime is defined in terms of x. So if we want to know the f prime at a specific value for x, we just plug it in. H of 2 times g prime of 2, and you can see where this is going, hopefully. G of 2 times h prime of 2. You just replace, just like you've done for years. You want to know the value of a function at a certain x coordinate, so you plug it in. H of 2 is negative 1, so you're just replacing, you're just now substituting in what those values are that were given to you initially. G prime of 2 is negative 2, G of 2 is 3, and h prime of 2 is 4, all over h of 2 squared, so negative 1 squared. That's nice, so that's just going to be 1. So we have 2 minus 12, and so we get negative 10. So negative 10 is f prime of 2. I'm glad we didn't have need any more space, because we didn't have any. So that's it.